This video is on the algebra topics of combining like terms, the distributive property, and simplifying variables. So there may be some questions on the ACT where you have to combine like terms. So let's look at a little bit of these keywords. A term could be a constant or a variable in an expression or even in an equation. So when we're talking about a common term with respect to variables, the common terms have to have the same variable. They all have to be x or all have to be y or whatever the variable name is, and it has to have the same exponent. So what we mean is we cannot combine with addition or subtraction x squared and x to the fourth. They have the same variable of x, but they have different exponents. We have the 2 and the 4, and we can't combine those with addition or subtraction any further. When we look at adding x and y, that's as far as you can combine those terms because x and y are different variables. You'll have some examples to work on combining like terms and get some practice with this. Now let's talk about the distributive property. Remember the distributive property, we're distributing usually a single term outside of an expression through to each term within the expression. So what we're looking at doing is really multiplying that outside term by each of the terms that are within the parentheses. And this example will show us what we're talking about here. So we have the 4, which is on the outside of the parentheses, and we're going to distribute that 4 into the x minus 2. So to do that, we have to multiply 4 times x and 4 times negative 2. And when we do that, we come up with 4x minus 8. This is the simplified version of this answer. We cannot combine because on the first term we have 4x, we have that variable of x, and then we have the 8, that is a constant. So this is as far as we can simplify this expression. One of the biggest things that we see on the ACT, they like to see you working with negative numbers a lot when you're distributing, whether the number on the outside is negative or, like for example in this case we had the x minus 2. They want to see how you're going to handle any negative or subtraction. So keep an eye on that. Make sure you're paying attention to when you're using those terms. Now, simplifying variables, we kind of have touched on all this. This is all sort of related. So when we're simplifying variables, we're finding an equivalent expression just in a simpler form. We're simplifying expressions. In order to simplify variables, we may have to combine like terms, maybe do some factoring or simplifying exponents. There's a number of techniques and operations that you have learned that you can apply to simplify an expression or an equation. So let's take a look at this example. If we have 3x plus 4 plus 6x, all that quantity times x squared, all of that divided by x to the third. So we have several different terms here. We have a constant value of 4, we have a variable of x, and the variable has different terms that are raised to different powers. If you'll remember, when you're dividing with exponents, we subtract the exponents, and that's how we get the x squared subtracts out from the x to the third, and we're left with x to the first really in the denominator. We combined the 3x plus the 6x to give us 9x. And the answer 9x plus 4 over x is a simplified answer. You could see that as an answer choice if you were asked to simplify, or you could see where we have divided the x through each term. The 9x over x just gives us 9, and the 4 over x is as far as we can simplify. So you could see either of these as answer choices. It just depends on what they put down in the question. But the main thing is we can only simplify when we have the same variables. We're going to make use of what we know about combining like terms, simplifying exponents, and those sort of things. Now let's take a look at this ACT type question. Pause the video here, work this question, and we'll come back and work it together. It says for all positive real numbers y, which expression is equivalent to, we have an overall quotient expression here. In the numerator, we have y to the 12th divided by y to the 5th. All of that is divided by 1 over y to the 4th. So we're going to make use of what we know about handling fractions with division. We'll take our original expression, and remember, when you have fractions and you're dividing, it's the same as multiplying times the reciprocal of the denominator. So we have y to the 12th over y to the 5th. That's multiplied. We just flip-flopped and multiplied y to the 4th over 1. Then we can use our operations that we know how to handle when we multiply variables. We can add the exponents, and when we divide, we subtract the exponents. And so we can simplify here, and it's the same as saying what we did is we subtract the 12 minus 5, and we have y to the 7th times y to the 4th. Now we'll add the exponents. 7 plus 4 is 11, and we have choice E, y to the 11th. That is the same. We've simplified the expression that we were originally given. Both expressions are equivalent. Y to the 11th is the simplified form.